So far, we already have 4 lectures about IoT, business model, and data analytics tutorial you learn at home with the YouTube. And through the lectures and tutorials, I quickly you start to realize the potential of IoT business product. It starts to help us to transform the product-based business model to service business model, such as sharing economy, and then move to outcome-based business model. Outcome-based means actually we do not need to have a car, we just want to move. If IoT and related business product can help us to achieve the goal without owning the real asset, and it will be lovely. And so far we talked a lot about this on paper, which is quite theoretical. And today we have the honor to have guest speakers from Advantech, and which is the largest industrial computer company in the world. And today's speaker is Dr. Allan Young. And Dr. Allan Young now is a Chief Technology Officer in Advantech on their executive team. And Dr. Young has a very strong background, not only in academics, but also in industry. And Dr. Young graduated from our university in the electronical engineering department, and later went to States for PhD in computer science at Yale University. And after that, he started to work in several distinguished companies in the world, such as IBM T.J. Watson Research Center, Prudential Financial, Tiger Management, and GSUN Securities, and Ever Media, and now as a CTO in Advantech. And in his team, and he started to work on several projects related to cloud computing, edge computing, and also develop a business consulting service in Advantech, and which were related to our group IoT project we will work on. And I do today, and you will learn the cutting-edge practice in the industry. Advantech is leading industry in this area. And let's give applause to Dr. Young. Thank you for giving a talk.
Thanks, Professor Young's kind introduction. It's my pleasure to be able to have probably 1 hour real time to share the perspective of Advantech toward the industrial IoT, right? There is quite a lot of buzz regarding what possibility that Internet of Things may bring, and gradually it has become apparent that the bulk of the business value actually is in the industrial scenario. So what is the industrial scenario? It's basically not consumer, not home, not office. These are pretty big segments, but away from these 3 segments, everything else is industrial scenarios. Later on, I will give more detail about what we do and why industrial IoT is going to be the next big thing. About Q4 of year 2016, Steve Case wrote this book called The Third Wave. Steve Case was the founder of American Online, which started doing business by providing a portal site. Well, at the moment, there wasn't even the internet, but it's the dial-up modem giving the internet connectivity for home users by dialing up through their voice line, connecting to some ISP at the moment, right? And that ISP then route the some preliminary internet services to these home subscribers, such as emails. All right, so just for the sake of emails, there are already a lot of American residents who were willing to pay a monthly subscription fees for the connectivity. So he roughly divided the evolution of information technology, information industry into 3 phases. The first phase being the 15 years from 1985 to roughly year 2000, it kind of started with Apple II, then IBM PC, then the boom of the personal computers. Apple II started from home use. A lot of family bought Apple II for their kids. But then gradually their application developers put in worthwhile application to do word processing, to do spreadsheet, to play games. And then IBM found this to be a lucrative segment, right? So they chime in with IBM PC. And then the era of personal computer exploded. And then IBM cut in from the from the office use scenario. And there were lots of applications being written for productivity's sake. And remember, the path of technology evolution sometimes take unpredictable turns. So starting from a single workstation to improve office clerics' works is quickly developed network connectivity. Around year 1980, DARPA, U.S. Defense Department Advanced Research, they funded some research on computer network. At those days, computer network were not as convenient as everybody is enjoying right now. It actually was an experiment trying to connect the computers together. Right? So gradually evolved to roughly year 1990, computer networking actually became an option, an expensive option for computers to be added to their PC. And then a lot of enterprises, they were willing to pay premium added network cards to connect the computers together, because it used to be you have to use floppy disk or other means to exchange the data across different computers, and it was very inconvenient. So there were a business boom on related software development, and there was a company called Novell. If you dig into all the history of how the PC evolved, and then Microsoft integrated computer network feature into the Windows, and then integrated the so-called graphical user interface. But then the computer networking took a huge jump of utility from just exchanging the data for productivity's sake between the workstations or between the PCs. Gradually, there were people found out that being able to connect all the PCs together, there was another layer of another degree of magnitude larger of business value, just being connected. And there were portal sites, there were browsers propping up, right? And at the moment, a company called Netscape, spun off from UIUC. What did they do? They just wrote the first web browser. And the graduate student, some of you are graduate students, one graduate student called Mark Andreessen, participated in the Netscape effort and made himself hundreds of $millions within probably 3-4 years. Browser quickly attracted a lot of users' attention because it was, at the moment, the most convenient way of reaching out to abundance of information offered in the form of internet contents. And then, Yahoo sprung up, and then tons of so-called search engine company at the moment came up. So at every point in time, with the permission of technology, there were always new opportunities by combining the technology with practical utility, right? And if you can find a huge targeted addressable market, you can really make yourself a quick fortune, all right? And then the internet quickly went above information, went beyond portal sites. Then there were lots of innovation, right? This course is about innovation, but with IoT. But then at the moment, the innovation were, now what can I do in business with all this fresh audience reaching out to us, to me, via the internet connectivity. So there were a lot of .com companies started. And then there were toys.com, there were fortune.com, there were pets.com, and there were amazon.com. Most of those .com went away because they really did not find a sustaining comparative advantage, or they have not found a really solid business position. And they probably also did not develop a really solid technology core to underpin their competitiveness. Right? So roughly around year 2000, there were this .com bubble. Many of these startups, just with the suffix something, xyz.com, the day of IPO, everybody jump in, and then you routinely expect you will get probably 2-3 times of return in the first day of your stock being listed. And many of those did not even have revenue, they just had a site, right? And of course, they did not really catch the real value of, or the real essence of what is it all about, right? Connectivity is a huge enabler to something of true value. And you have to bundle a package of additional competencies in order to take good advantage of connectivity or the potential customer coming into your door through connectivity. So roughly at year 2000, the .com bubble busted in March of year 2000, right? And there were like 1.5 years of good time of gold rush. The real essence of the opportunity at the moment was really about connectivity, was about getting online, and was about a new way of reaching out to an unlimited amount of potential audience or customers through the internet connectivity, regardless of where they are, regardless of what time zone it is. So it's an unbounded scope, instant connection between service or product provider and their targeted audience. So that bandwidth is unlimited. That weight of communication is the imagination is the limit. So from year 2000, that industry quickly shifted away from computer hardware to connectivity or information-based service. What are they? Probably at the moment nobody realized that social was or it still is a basic human needs, right? And in the past, the business model of offering social service is probably dating service that you have to go to some physical premises to meet up. But then online, social become a big deal. Facebook. And Facebook actually was not the only social site. Facebook really had to beat down a lot of competition to be the social site around year 2005. E-commerce, right? Selling stuff on the internet. Amazon.com started by selling books. But selling books was just for proving the business model, proving the technology of an unlimited entries of offers in an online store, and how to offer ultimate convenience for shoppers on site with one click of ordering. And then you move on, you have hotel or hotel booking of Airbnb, you have car hailing service, you have Uber, and then ton of it. All the consumer needs, right? Chinese say 食衣住行娱乐, basically eat, clothing, living, transportation, entertainment, education. Pretty much all this can be met with this sort of business model. So suddenly all the traditional business paradigm got disrupted. a lot of music industry got disrupted. A lot of movie industry got disrupted. And the ensuing business all the way till today, roughly the 17 years, 18 years of evolution quickly changed a lot of consumer-related industries across the board, no exception. All right, and what make it really accelerated to a frenzy pace is the launch of the first smartphone in year 2007. When Apple Steve Jobs announced the first generation of Apple iPhone, the internet connectivity suddenly jumped from notebook to cell phone. And cell phone is portable. Cell phone is with you anytime, anywhere. You are tethered to the internet, regardless of where you are. Doesn't matter whether you are at the desk or you are in the bed or in the bathroom. Right? Admit it. Most of us are tethered to your cell phone. And that basically formed an internet of human beings. Right? And what is amazing is every one of us, or most of us, are voluntarily offering all the information about us into that cell phone. Right, and then via the cell phone into some sort of cloud services, either social, shopping, transportation, your browsing preferences, all that. So cell phone really make the internet of human being and the business model around all our needs into a totally different structure. In this book, then it moved forward to year 2015, when the connectivity, thanks to the explosion of mobile phone come with a lot of wireless communication capability, a lot of sensors. So if you just peel off the sensor and the wireless connectivity, and then attach it to assets of interest, you get Internet of Things, right? And asset of interest, what are they? If we look around ourselves, if we look beyond the products that we are using, we're consuming today, how do they come about? Most of them, or all of them, come from some factories, come from an underpinning manufacturing processes, all right? And industry, manufacturing industry itself has gone through several waves of evolution in the past, from human labor to machine labor, from homegrown type of productivity to assembly line of mass production, bringing into automation and information technology, IT, to manage all the details to boost the productivity. So human actually has invented a fairly efficient production infrastructure in the past 100 years. But then again, if we are able to combine the information technology that we have introduced into the manufacturing facility in the past 15, 20 years with so-called OT technology, operation technology, which means that if we can start to monitor many of the machinery that we use in the production process, there is another layer of productivity gain that we can get that we did not even think was possible just barely 2-3 years ago. It's the Industry 4.0 revolution, all right? So to quickly summarize what has been driving this very fast pace of technology-driven industrial evolution, is basically come from IoT, right? And take an analogy for consumer. For every one of us, your cell phone is your sensor. And you pump everything about you into the cell phone, and the cell phone route it out to the backbone services. But then for machine, they don't know what to enter, so you take the sensors, either vibration, either audio, either temperature, either voltage, either current, or whatever signal of interest, signal of value, you extract it out of the machines. And if the context is about environmental monitoring, then you attach the sensor to monitor the water, the air. And if the context is about making transportation more efficient or more safer, then you probably attach it to the locomotive and to cars, and so on and so forth. A lot of the tools, a lot of the machines, a lot of the context around us, the utility, the machinery, the environment, whatever of interest, whatever of value that is not human, we now have a way to inexpensively attach to them and extract the information out of it. And then with the deluge of the sensor data, you get big data. In the past 10 years, thanks to the internet of human beings, we already pump a huge amount of data into all the internet giants. They have come up a way of dealing with this big data in a useful way and in a way that is very profitable, right? So the machine learning, the so-called the AI approach in dealing with big data has actually come a long way and proven to be very effective. So to deal with big data, you brought in machine learning, and Professor Yan told me that all of you know how to write programs, and many of you know how to write R. Okay, so with R, you need data. You need good data. You need data with good values. Otherwise, garbage in, garbage out. So data, machine learning, AI, and then the toolkit. What do you use to run the program you write to deal with big enough data? Tons of it come from open source packages. In the past 10, 15 years, open source has really redefined the software industry to such an extent that Microsoft had decided to change their business model about 4 years ago when the new CEO came on board. They changed from license selling to subscription cloud service-based selling, all right? Software industry has been completely redefined by open source movement. Later on, I will probably share a little bit about how fundamental it is to human civilization. It's a big deal. Then it's the cloud platform. Used to be, you have your computer, right? Or enterprise has their data center, and it's bounded. It's bounded, right? Your computer, your notebook, your cell phone is your computer. That enterprise data room servers is their server, their data room. It's kind of bounded, managed by them within their own walled garden. But then the huge amount of consumer needs in order to provide competitive cloud services, or competitive services online, doesn't matter whether it's cloud or whatever. In order to provide competitive cloud services online to a large scale of audience, cloud platform proved to be the most effective architecture. It's highly scalable. Doesn't matter whether I'm dealing with thousands of customers or billions of customers. Cloud architecture is the way to go because it can harness the computation power of cluster of unbounded scale, right? That's the power of the cloud platform that brought us. So we use cloud platform as almost like a huge reservoir of compute resource, and we share from the reservoir. We don't keep our own water tank anymore, all right? And then another very important thing is fast innovation and market validation. You have innovation, then you have implementation of your innovation in some form. You engage your targeted customer quickly and gain feedback quickly, and then you iterate on that very quickly. You don't, hold your ideas and then develop for like 1 year and then meet your customer. That's too slow. A quick check of the top 10 companies in terms of market cap 10 years ago and today. 10 years ago, you see energy company, oil company, petrol, China, Exxon, and then GE industrial company, China Mobile, banking, and the rest, right? Today, the top 10 company Apple, Google, Microsoft, Amazon, Facebook, all internet platform companies. Number 6, Tencent, China. Then Berkshire, Warren Buffett's company, holds lots of Apple stocks, all right? And Alibaba, this is the top 8. Imagine what will be this list 10 years down the road, right? The technology, the business model, what are the most competitive structure, combination of that? It's platform, right? It's the cloud platform that actually combining the super powerful technology with the business model and with the data capability to really meet the customer's demand. Industry research published by McKinsey, by the way, this is public. During the full-blown IoT business 10 years down the road, when they did the research, which projected at 2025, the top industry of IoT value will be smart factory, smart city, industry scenarios, and the rest. About the phase 2, 3 phases, all right? The 3 phases of IoT evolution. The first phase will be the embedded platform, the proliferation of that. It's just like the proliferation of cell phones, that everybody has one. This first step, connecting every individual. And in the industrial scenario, is connecting all the assets of interest or point of interest. The second stage, in fact, is the platform that is that is convenient for the service provider to develop their services. It's just like Apple or Google, they need to provide a development platform for the app developers to develop their application more productively. All right, so this is the second stage, which is the platform, the formation of a platform. Then the 70 or 80% of the value actually lies in the service that all the edge devices gather the data. The platform provides a productive environment for the cloud service provider to build their service. So there are these 3 phases, and if we take an analogy on the consumer cloud service, is pretty much similar, right? This is the cell phone proliferation period. This is the Google and Apple providing their development platform to the app developers. Then here is the service provider coming up with their apps, like search, like social media, like all type of the like Uber, like Airbnb, and the like. All right. So the main theme of this talk, we are basically to share with you that how do we go about extending our business model from phase 1 to phase 2. And for the phase 3, we are basically going to partner with those who have deep domain knowledge in vertical segments through a business model called co-creation. Right? Many of the vertical domain leaders, whether it is in oil, transportation, medical, or retail, you name it, usually they are good at their own vertical segment, but they are not that well equipped with cloud technology talents. Right? So the business model here is we would provide them with a rich collection of edge modules to acquire the data, acquire useful data at the edge, then provide them with a convenient data platform for them to develop their service on. And then the third stage will be the partnership with the domain leaders. A quick introduction about Advantech. We were founded roughly 35 years ago. Globally, we have roughly 8,000 people. Revenue as of last year was roughly $1.4 billion. That's us. And the fields of services, we do a lot of so-called IPCs, industrial PCs, basically offering compute platform for different kind of business segments that is not consumer, not home, not office, but everything else, all right? Staff distribution, headquartered in Taiwan, in China, then USA, Europe, North Asia, and Southeast Asia. The revenue trajectory of Advantech in the past 35 years, we only had one down year, which is year 2009 after the financial crisis. This revenue trajectory is very unique in a way that is super robust, right? One core reason for that is because of the extreme diversification of business exposures, right? Since we do industrial segments, many of our customers actually, they only buy small amount of IPCs for their very unique niches. So it's an aggregation with a lot of customized products for spatial industrial use. And thanks to this wide diversification, we have really high stability in terms of our revenue track record and our profitabilities. And in a way that a lot of the insurance company, a lot of the pension fund, and a lot of the company are looking for low volatility returns, they actually look into Advantech stocks. The global brands ranking as of last year, it's a survey conducted by Interbrand, commissioned by the government of Taiwan, right? Advantech is number 6, and it's only after a handful of other companies, and some of them in banking, some of them in food, right? Number 6. So our business model up to this point is fairly successful, but then selling the embedded system for automation, for control, for system integration comes to a stage that we have to extend to the phase 2 by embracing IoTs and bring in a data platform. This is the data platform that I have mentioned so many times. If we look into areas of this structure, right? At the middle actually is the platform as a service, it's PaaS. It sits on top of some cloud platform, right? And at the center of it is the data infrastructure. And some of you may have exposure on some sort of programming paradigm, but just it's enough to just know that at this core of the data infra, we offer SQL database, we offer non-SQL database, and we also offer so-called time series database services. So SQL database basically is a relational database that all the attributes are grouped into a tuple, right? NoSQL basically is unstructured data you just collect from some really discrete and probably not related, not tightly related source. And then there is this time series database where you have sensor attached to machine, and probably every second you pick out 2,000 sample points in order to make sure that the machinery is operating in the best, the most optimized form. So at the center is the data core, and then for the data pumping into this data it go through an IoT hub. It's basically a message queue with publisher subscriber communication approach, and that links this cloud data platform with all the data source on the ground. All right, so that's the message queue, and then here is the compute resource management substrate. The compute resource, remember I have mentioned that we need to be hugely scalable just because it's part of the required nature of being a cloud service. Being a cloud service, you need to be able to deal with very few customers. You need to be able to deal with large amount of customers. And in between, the setup and configuration time may be just a few hours, all right? So elastic scaling, high availability, doesn't matter whether hardware is up or down, you have to deal with it, all right? And the service has to be always on. And then you have so-called customer management. It's identity and access management to make sure when we convert this cloud service into a business, we know how to track, how to bill each customer. So these four modules is independent from any specific vertical domains. Doesn't matter if you want to do cloud services for transportation or for equipment monitoring or for hospital or for retail or for factory. If you want to do cloud service, you'll have to deal with this. So we factor out the commonality and then provide this module in the ready package. Then it comes the data analytics. Remember, this is the data-centric design. And the second important feature of it is designed for evolution. Right? If you have written program, you know that if you write your program according to some sort of spec, if the spec evolves, you sometimes has to change your code. And if you do not structure the code modularly enough, sometimes you have to totally rewrite your code. Sometimes the spec may just change a little bit. So this architecture basically segregates the data layer, and then you lay on top of on top of it with an analytics layer. It's a framework that supports TensorFlow and Caffe and R as well. And then if your data set is really big, you can also bring in GPU acceleration to speed up the training of the inference engine, right? But it's totally independent from the data layer, okay? And then there is so-called visualization toolkit that would quickly afford the solution developer to put together a management dashboard and user interactivity, right, to interact with the targeted audience. So this is the data platform that we offer to IoT solution developers. And on top of it is then targeting all different scenarios of industrial usage. And beneath it is the infrastructure as a service, which is the service provider that really offer the compute hardware in some sort of mega data center format. It could be Microsoft Azure or Amazon Web Service or China's Aliyun, right? And we also have run into some scenario where a customer is so insistent that their data has to stay with their data center. So we also offer private cloud option based on the OpenStack. So you see a lot of names here, OpenStack, RabbitMQ, Influx, and all that. It's all open source packages. Without all these open source packages, it's almost impossible to build this platform up with not so big a team within a relatively short time, right? So this is the infrastructure layer that really offer the compute resource. This is the data infrastructure layer. And then you have the analytics, and then you have the visualization on top, and then you have scalable infrastructure, and then you have customer management. You pretty much have all you need to deal with cloud services. But then the ugly reality of so-called industrial scenario comes up. Contrast to consumer scenario, where your demand for booking a hotel or getting acquainted with your friends is pretty much universal. When it moves to the industrial scenario, it becomes fragmented. The transportation requirement is totally different from hospital's requirement. And then it's totally different from retail, different from hospitals, medical certification. For more consumer inclined type of business, they are not used to this sort of fragmented world. If you produce a cell phone, you sell this cell phone pretty much to the global market, pending the certification of ACC and the like. You build a notebook, you sell it globally, pending the power adapter differences. But then if you build something for railroad, you probably cannot transfer it to oil field. And you build something for oil field, you probably cannot transfer it to retail. Okay? So the fragmented standard actually needs to be taken care of at the edge. And it just so happened that Advantech's business model, in the past we have been selling computing platform to various different type of verticals. And we're used to that. And we have accumulated experiences in the past 30 years in dealing with these fragmented standards. It just so happened that we did not expect IoT would come around. We did not expect the data would become the king. But we were there. So it's this at the bottom is all the edge assets, of all the vertical industry, you name it. And sometimes we actually have a customer who sell IoT services to cattle ranches, Internet of cows. Think about it. How do you optimize the productivity of your cows on your farm? They attach a tag with G sensor and wireless communication to the ear of all the cows on the ranch. And they measure the pace and number of steps of each cow. And pretty much from there, they can do deep learning and extract the status of the cow, whether it's in good health situation, whether it's in a certain state of health, and they can predict how much milk they can collect from each of them. And they want to roll it out. This is actually a European company, and they want to roll that solution to China. Think about it. It's cattle ranch business. The technology brought into it that can actually improve the productivity of that. So it's sensing, and then tens of sensors or hundreds of sensors aggregated to a gateway to the pass, and then that's the real value added in. Everything below is plumbing. It's the infra. But without the plumbing, without the infra, without the data, you do not have the new paradigm of your business. So it's the domain, SaaS, and then it's cloud. So from the edge to tomorrow's domain application, it's a long distance. So this is where the traditional business is today. They build, operate these edge asset, whether static or mobile. Tomorrow they want to connect all these assets and extract, acquire the data and build model and then do optimization of performances. But then in between, you need sensor, you need gateway, you need pass, and then you need the domain knowledge. All right, so benefited users of this data platform, one is the industrial software as a service providers. If you want to go out and start up a company, you can do consumer scenario, you can do industrial scenario. And the nature of the industrial scenario, you already see the trajectory of Advantech's revenue path. It's hugely stable, slow to get in and slow to get out. You are doing something to improve the productivity of your customer. It's not a phase, it's not a fashion, it's not a nice to have. You are part of their core infrastructure of their business. It's a different thing, okay? And asset builders, whether you're building machines or you are raising cattle, same thing. And then asset operators in an aggregated premises, factory, oil field, and the like. There is a traditional way of running this, but then there is a new way of running this through internet, connected assets, and then data acquisition, data analytics, and then visualization. So This is the monitoring dashboard of the data platform in action. We now have 3 instances running. This is Hong Kong, this is Beijing. A few days ago, we light up another instance in Hangzhou, where Aliyun is. So these are live instances, and I will provide some URL for you to click into if you are interested in knowing what we are showing. So high reliability, running on a cluster of roughly 80 virtual machines, and it can quickly scale. And the purpose of it is to make industrial data acquisition much easier and to speed up the IoT solution deployment. One example is wind turbine in an eastern province in China. Wind turbine, each of them costs quite a few $1 million US dollar to build. Disruption by unexpected problem is usually very very painful. So the operator, they would like to attach a sensor to the wind turbine and then to make sure all this is operating at their top shape, right? And if there is any unexpected noise, unexpected fluctuation of the rotation speed and the like, they get notification early on and fix it before it breaks down. Okay, so as I mentioned, 2 instances already up and running in Hong Kong and Beijing, and right now we build it on top of Microsoft's data center. This is the global deployment map of Microsoft data centers across the map. This design of WisePass, which is the data platform, has at least 2 very important business benefit. One, it is cross cloud service provider. Today, if it's to your best benefit in working with Amazon, you stay with Amazon. Tomorrow, if it's Ali, you can move to Ali seamlessly. All right. So without being locked down, you have better bargaining positions. And secondly, it is built mostly on top of open source packages. Some customer ask us how big a barrier it is to operate these open source packages. I kind of joke with him that quantum mechanics is also open source. You can go and read the textbook and learn it well, and make some use of it. All these open source packages there is fairly complicated, and if you are willing to invest the staff to learn it first and then know how to operate it, be our guest. But then the guarantee is that it's open source. In the case that somehow we are not there for you, you can find another to serve you. All right. Some examples, and probably I don't have time to go in, but I'll try. Oops. There are URL for you to click into and to get a feel if you are curious enough. So if you are interested, you can go about putting up the dashboard, and behind it's all driven by the data infrastructure in the back running either in Hong Kong or in Beijing. Okay, and it's also possible to run it from your own cluster if you so choose. Yeah. Okay. So you probably need to turn the resolution. Okay. So it takes a little bit of time to load up. So I'll stop here and see if you have any question.